Okay, so we're going to be in the Bay of Fundy, and the water depth of the water around a harbor dock changes between low tide and high tide, as shown in the graph below. So in this case, we're not drawing the graph, we're just going to look at reading it. So how long does one tide cycle take? So if I look, the bottom is here, and the bottom is here again. So 15 minus 3 is 12, so it takes 12 hours. Or I could have looked here, I see that point again over here. Again, it's 12 hours. So how long does the cycle take? Therefore, it takes 12 hours. What is the high? How high is high tide? Well, if I look, the highest point on the graph is up here. And I would say that it's 15.5 meters at high tide. Wants to know when 3 times of high tide would occur. So if I look, the first time high tide occurs is at 9 hours. So the first time is at 9 hours. The next time it will occur will be 12 hours later because it takes 12 hours to do one cycle. So that means it will occur again at 21 hours. And if I check the graph, that's when it occurs again. If I look for the third time, I'm going to start, well, now I'm at 21 hours. I'm going to add 12 more hours because it's 12 hours after that. So it's now at 33 hours. What would be the water height at low tide? So if I look, it's right here. The low tide is 1.5 meters at low tide. Wants me to determine an equation. So I now have the maximum and minimum. So now I can figure out the amplitude, which is the maximum minus the minimum, and I'm going to divide that by 2. The amplitude is 7. My K value is my max plus my min divided by 2. So my K value is 8.5. My B value, so I figure it out by doing the period is equal to 360 divided by B. I isolate for B. And my B value is 30. I'm going to put in my K value on my graph. Okay, so that occurs at 8.5. Okay, so now I can use that to find the cycles that I want. So I might as well take the easy one. So I can say that the cycle I'm going to use is right here. Just checking to make sure they don't tell me which one I have to use. So I'm going to use that one. So it is a sine graph, and it's got the vertical reflection because it goes down first. So I can say that I'm going to do y is equal to, I have the amplitude of 7, but I need to add in a vertical reflection. My B value is 30. I've chosen no phase shift. And I'm going to add 8.5 because that's my K value. I'm just going to say that the phase shift is none. So now they're saying, well, low tide occurs at 3 a.m. So that's right here. So instead of just being 3 hours, this is now 3 a.m. And they want to know what time high tide would occur. Well, if I look, high tide occurs 6 hours later. So right here. So this would be 9 a.m. So therefore, it would occur at 9 o'clock a.m. So it says if low tide occurs at 3 a.m., when would I expect, what height would I expect the water to be at 6 a.m. the next day? So it doesn't really matter that it's the next day or not. It would simply be 3 hours after low tide. So if I look, there's 3 a.m. So it's 3 hours after low tide at 6, so it'll be at my midline at 8.5. So the ship needs 3.5 meters of water at least to be safe. Can it enter the harbor between 3 p.m. and 4 p.m.? Well, 3 p.m. is the same thing as 15 hours, and 4 p.m. is the same thing as 16 hours. So I'm going to check at 3, which is 15 hours, and then I'll check at 4, which is at 16 hours, and see if it's good enough. So let's check at 15. So I'm going to take the equation I did, and in place of x, I'm going to put 15. Remember, this is on a 24-hour cycle, so we need to make sure we change it. And then it keeps going even after that. You got to remember it's 24 and then so on and so forth. Okay, so plus 8.5, so I'm going to simplify. So I get 450. So I'm going to grab a calculator and I'm going to plug that in. Close bracket. And then I have to add 8.5 and I get 1.5. So not safe. Let's see if later on though it's safe. So this time I'm going to plug in 16. So I'm going to simplify this. And then I'm going to plug that into my calculator. Add 8.5. And I get 2.45 approximately. So between here and here, it only goes from 1.5 to 2.45. And it needs a minimum of 3.5, so therefore it would not be safe.